48 says that Allison's office has a water cooler that uses a cone-shaped paper cup like the one shown in the diagram to the right. She fills the cup up half full with water, as shown by the shaded region. If 30 cubic centimeters holds approximately 1 ounce of water, which is the best approximation for the amount of additional water Allison needs to fill the cup completely? Okay, so they said that this is a cone, this is the cup of water, and it's this full. They said it's half full here. Now, they need to know how much water would fit in the remaining portion. Okay, well, we don't know how to find the volume, which is the filling of this figure, of the cone with the top cut off. But we do know how to find the volume of the entire cone, and then the smaller one, and then we could subtract from the total this portion, and then we would be left with this the amount to fill it up completely. So it sounds like a lot of work, but if we take it step by step, I'm very sure that we can tackle this easily. So, like I said, we're going to have to find the portion or the amount of water in this half portion, and then the amount that's in the entire portion, and subtract. So let's start with the total volume of the cone. Volume of a cone is V equals 1/3 big B H. Okay, so I'm going to go ahead and label. This is my total of the cone. It's a nice little cone, isn't it? Okay, and then over here, I'll do the work for the half, the bottom half of the cone. Okay, so the total, V equals 1/3 big BH, and the same formula would apply over here. We're just going to change the numbers that we use because our dimensions will change. Okay, so now well, actually we can plug in our big B, and then we'll go back to just finding the total. So big B, we know, stands for area of the base. Don't forget, when you sit down in that test room, get your reference materials and do the brain dump. That is the #1 most important step. Write down, draw those arrows, write your formulas, do the brain dump, and get everything out that you can. So, for big B of a cone, they're asking you to find the area of the base. Well, the base of a cone is a circle, so you're actually going to have to go up higher on the reference materials and look for the formula for the area of a circle, which is A equals pi r squared. So where we see big B on both of these formulas, we're going to expand and have pi r squared, and then we'll copy everything else down. Okay, now back to just finding the total surface area, or the total volume of the cone. We can just plug in our numbers and solve, and then we are going to subtract at the end, and we'll have our answer. So, we will have 1/3 times pi times r. Well, we know that the r of the small cone is 1.5. However, on the total cone, they give us a diameter of 6. So, divide the diameter by 2, you'll have a radius of 3. So, we'll have 3 squared times h. The height of the entire cone is 4 and 4. So, the total height is 8. We can plug that entire thing into our calculator. We have 1/3 times pi, 3 squared, and 8. Just going to hit enter because it matches exactly what I should have typed in. 1/3 pi r squared 8. And I'm left with 75.3982. That's the volume of this entire cone. Now, they only want the top part, so let's find this bottom part and then see what the remaining area would be. So, once again, we're going to have 1/3 times pi times r squared. R is 1.5 times our height. Well, the height of the smaller area is just 4. This is 4. So, I'm going to use the same thing, but I'm going to change my numbers. My R is now 1.5, and my height is now 4. I'm just going to verify that I plugged in all the numbers correctly. 1/3 times pi times 1.5 squared times 4. Hit enter. And I have 9.42478. Okay, so if I do total minus the smaller region, it will give me the remaining portion. I am going to just copy the numbers down on the calculator because they're actually long repeating decimals, or not repeating decimals, non-terminating decimals, and then hit enter. And I have 65.9734. Okay, so this is the volume of this top region. But we're still not done. We have to convert it to the ounces of water. So we know that the volume of this region is 65.97 cubic centimeters. But they want to know how many ounces of water can go into those cubic centimeters. Well, they said that 30 cubic centimeters will hold 1 ounce. So for every ounce, you need 30 cubic centimeters. Well, we have 65 to work with. So if we divide by 30, it should give us how many ounces it will hold. 2.19911. So what I did there, I just said that if 30 cubic centimeters would hold 1 ounce, I set it equal to the proportion of 65.9734 cubic centimeters, and I solved for how many ounces would be held within that volume. Technically, I cross-multiplied here, which times 1, anything times 1 is itself. So I was left with this 65.9734, and then I divided by the lonely guy, which was 30. So I did 65 divided by 30, and I was left with 2.19911. And I know that decimal would keep going, but the calculator just stops at 5 decimal places. So, which of my answer choices does this match up to? I see that they only rounded to the 10th, so let's round our answer. Rounding to the 10th place, look at the 100ths. If it's 5 or larger, round up. 9 is indeed larger than 5, so this would become 2.2, which is answer choice C. There's so much room for error in these problems, so just be really mindful when you're plugging in your formulas, what you're using for big B, which formula you're using, if it's volume or surface area, and then paying attention to those little nuggets that they give you earlier in the problem.